Meelis Kull from Tartu University, subject machine learning. We probably can understand that have you talking to us about new robotic rules, or what is the subject, but tell yourself.
Hi, my name is Meelis Kull. I'm happy to present here Foundations of Secure Digital Solutions and Artificial Intelligence as a project by me, Helgar Lippmaa, Raul Vitsente, and Vesal Voidani from the University of Tartu. So why this research? The digital systems, digital solutions are having rising importance. They have been very important for Estonia for a long time already, but I would say the importance is still rising, and there are some established digital solutions and some that are emerging, and they all need attention to make sure that they correctly function and that they are secure. And that is getting quite challenging because the systems themselves are more and more complex. If not in amount of lines of code, then at least by the inclusion of the element of AI in them. And that makes them conceptually already quite a bit more complex to work with and to have guarantees about. But also, I mean, software bugs are still an issue. There are malicious attacks and privacy leakages that we are also, let's say, worried about, as Ryan said, or concerned about, that we want to avoid. And there can be more kind of problems that are kind of combining these multiple fields. If you think of kind of the digital solution as a whole, as a architecture, which can have some problems that are not just the individual components, but more kind of centrally causing problems. And so, therefore, the goal that we have is to create a foundation and methods for approaches that ensure the correctness and security of digital systems. So what do we need for that? We have this list of things to be concerned about, and then we need to look at what are the fields that are relevant for addressing those concerns. So certainly for AI, the machine learning and trustworthy AI fields are relevant. For software bugs, programming, and then also correctness verification. For attacks and privacy, there are many cryptographical methods that can be applied. Not only, but it's one of the tools that can be beneficial. And when we're talking about architectural problems, then we really need to look at all of those together as well. So to make this happen, we need to bring those groups of different capabilities and backgrounds and skills and bring them together. So we have here these mentioned topics of machine learning and trustworthy AI, programming and correctness verification, and cryptography, and particularly also the cryptographic proofs. So let's talk about each of them a bit separately. First, so foundations of trustworthy AI. Here we will have two topics. One is about AI systems that quantify their uncertainty. Why do we care about that? Well, because AI systems tend to occasionally make errors. And when they do, at least we want to have advanced warnings that, well, maybe the model is not so confident at this point, and it would report, oh, I'm not sure at this point, but now I'm sure. And then we want to have those kind of estimates of uncertainty to be calibrated in the same way as you think about as humans making statements. We want to make sure that humans are also not overconfident in what they say and not underconfident either. Then what is the key challenge there is how to achieve this kind of calibrated confidence in the face of context and the environment around us changing, so that you cannot train an AI model and hope that nothing changes after that training, so that deployment scenarios tend to have some differences compared to training, and that's the key challenge. And the directions that we're taking there is really do modeling of that context and deployment. Now, and another topic is to look at AI systems as a whole and how to ensure that they are trustworthy. Even kind of if there are subcomponents that are quite a bit less trustworthy, for example, machine learning-based solutions. And we also care about explainability there. And so the possible directions that we are considering are then about verifiable logical systems that are built on top of AI systems that are by nature unreliable, machine learning-based systems as an example, and then kind of around it, together with information, verified information from databases, there would be an overall system that behaves as expected. Moving on to the direction of cryptography. So we're looking, and that's Helger Lippmaa's group, at verifiable computation, which is something that is needed if you want to run really expensive computations, but you for some reason need to delegate that computation to somewhere, for example, as in cloud computation, or if there are other reasons why kind of computations need to be verifiably correct, as in e-voting. So, and for example, in machine learning, we might want to make sure that the models are trained in a way expected, so we maybe want some proofs about that. The key challenge is that although there exists some methods for that, there tends to be a really heavy overhead in doing so. If you want to ensure that the computation is kind of verifiably correct, then that adds magnitudes of more computation. And then the directions of research are about how to alleviate that problem, both in theory and then also in practice. And the third line of research is about then foundations of program verification with Vesal Voidani's group. And so there, it's about software verification that is automated and also explainable. So we get an explanation why this correct code is indeed correct and does what it is expected to do. And the goal is to use machine reasoning tools that would then kind of provide those explanations. And this could be even between multiple tools. So you might have multiple tools with different sets of, let's say, skills or competencies, and that would cooperatively verify the overall system, because the system might be so complicated that one single tool does not have the required, let's say, skills to address it. And then it's also to humans, of course. Eventually we want humans also to be able to get convinced that, yes, the program is correct. And so the challenge is that if there are many existing tools, but they also have very different representations. So when you take a bigger program to analyze this, it might not currently be possible to do that in practice. So the research direction again is cooperative and explainable verification. And these are kind of emerging fields, really kind of very new. But already Vesal Voidanis group has some recent papers there, and so this topic paves the way of integrating AI-powered tools responsibly. So this was now covering 3 groups separately, but then to combine, the collaboration, there are multiple collaboration points, and so particularly here, this verifiable computing for VC is one way to increase trustworthiness of AI. Explainable verification, as done by the kind of software verification group, is also one way of addressing the needs for building those complex zero-knowledge verification programs. And the third is cooperative verification with AI-powered heuristic tools. So here the AI side comes to help the software verification. So there are these kind of pairwise collaborations. And then also collaborations with private and public sector, where, and for AI there are many possibilities of applying, but e-governance being one of them, where trustworthiness is really important. The cryptography group will collaborate with the various companies that work already in zero-knowledge verification. And then the software verification tools are also something that are aimed to be available for the industry, and they are developed open source. The expected impact, trustworthy AI, is important because there are many opportunities out there to use AI, but many of those opportunities are waiting behind everything to be reliable and trustworthy enough, because the fields are maybe so kind of having high risks, like healthcare or automatic transportation. So we need to have trustworthiness. And so for verifiable computing and zero knowledge, there are many digital solutions that we want to ensure security of. And for the automated software verification, there is an overall impact in improving our software to make sure that it's less vulnerable. And so together, 3 research groups become also, with this project, more and more able to collaborate with the public and private sector, because they are kind of by, basically, you can see those 3 arrows that I showed you earlier. So 3 groups work more together with each other, and that there is a way to broaden and be able to also collaborate better with the public and private sector. And also adapting to new emerging challenges fast is something that can be done better with a bigger team of different capabilities. And very importantly, one reason why I think it's really important to do research in foundations is that that gives new talent that is really adaptable. People who can, who know the basics very, very well, very deep, and therefore can adapt to the really fast-changing environment. So we have a team planned here with 4 senior staff members, 4 PhD students. And to summarize, so these were the topics that I mentioned: collaborations and fast adaptation through researchers who are strong in foundations.
Thank you.
Thank you.
Well, questions? Please, Dan.
So we have a prototype that does zero knowledge on neural networks for facial recognition. Yes, as you said, the performance is a problem. Is there a way to work together on this further? Because we already have done the applied part, that works. Now it needs to go faster.
Yes, I'm sure there are ways to collaborate, so very happy to consider. That's really to approach then Helga Lippma's group. If you're wondering what this zero knowledge means, it's really about proving something that you know this, but you don't need to tell this thing. So I can prove you that I know this, let's say, I can prove you about my, for example, about possessing some piece of knowledge. For example, I can prove I know my private key without revealing you the key. So similar technologies for any kind of data.
More questions? I do have. Trustworthiness. Do I understand that one point of this research and development is somehow to try to create the system which is enough self-aware, telling that something is right or wrong, so that what is the, let's say, the philosophical point of turning point of this technology or concept, because as we know, a lot of samples have published hallucinating artificial intelligence systems, so that how you avoid that kind of hallucinations to be sure that actually what is made is more or less you can trust it.
Very good question. Hallucinations are, well, these are, let's say, statements that look like facts given out by, let's say, large language models, but they appear to be wrong. So how do we know whether they're right or wrong? Well, we need to go and check. For example, if it's a fact from a database, we can just go and check it. And that's one easy solution. But of course, things can get more complicated.
If there are more questions, then thank you.
Thank you.
Alar Kuusik.